Hello students, today we are going to study the topic isomerism. Okay, so what is the meaning of isomerism? It means the compound, two or more compounds are having same molecular formula but their properties are different. Okay, so here we can see in this isomerism the molecular formula is same but the properties are not similar. Okay, so broadly this isomerism, okay, here we can see it is broadly divided into two or classified into two, that is structural isomerism and stereoisomerism. Okay, so first let us study about the structural isomerism. Here structure itself means that here the molecular formula of two or more compounds will be same but they will differ in the structure. It means their structure will not be similar. Okay, so now here this structural isomerism is again classified into four. Okay, that is the chain isomerism, position isomerism, functional isomerism and metamerism. Okay, so coming to the chain isomerism, as the name suggests, it means the carbon atoms are arranged in the form of chain. Okay, and here chaining property is there in carbon, that is the catenation property, isn't it? So here in the chain isomerism we see what, that here take an example of butane C4H10. Okay, it can be represented in this manner. Okay, in the chain form manner. This is what, the normal butane. Okay, I can write what, N-butane. Okay, can write here normal butane. Now here this only same C4H10 can also be arranged in this manner. Okay, where one of the carbon has gone in branching, and so it is known as what, isobutane. So here we can see there is arrangement, the arrangement of carbon atoms, okay, here in this, okay, gives them different properties, thereby this is known as what, chain isomerism. Now coming to the position isomerism, okay, let us take the example C3H7OH, okay. Here we'll be seeing there will be a difference in the placement of the substituent atom or groups. So here you can see in this C3H7OH, here alcohol group, okay, OH group is attached at the last, at the end. And here we are seeing that this OH group is being attached in the middle of the carbon atom. Okay, so here there is a displacement or placement of the substituent atom or group is changed, and as the result it results in the formation of position isomerism. And here we will be seeing that even though having same molecular formula, okay, it is having different properties. Okay, now coming to the functional isomerism. Okay, when I say functional, it means here there will be a difference in the functional group. Okay, so taking the example C3H6O, okay, it can be arranged in this form where we are seeing ketone group is coming. Okay, and it can also be arranged in a form in which we are seeing which group is this, aldehyde group is this. So here there is a difference in the functional group, thereby it results in formation of what, functional isomerism. So here the molecular formula is similar, but due to the different functional group formed from the same molecular formula gives them different properties. Okay, now the next is the metamerism. What happens in this metamerism? Actually here there is the difference in the attachment of the alkyl groups to the same group, okay, which is present. Like here, this you can see this is the ether group, okay, and here what is attached? The alkyl groups which are attached on the left hand side and the right hand side. Okay, here in the first one you can see the methyl and here propyl. In the second one you can see ethyl and ethyl. Thereby they are having same molecular formula, but yes, the arrangement of these alkyl groups are different to the same functional group, isn't it? So what happens in this here the properties becomes different. Now let us study about the stereoisomerism. Okay, beta. So when we are talking about stereoisomerism, before that I want to ask you something. Okay, have you heard about stereo speakers? Okay, why do we use it? The stereo speakers, okay, so that the sound can be spread in whole space. Okay, here also the atoms are arranged in the space. How, I'll tell you right now. Okay, in stereoisomerism, actually it consists of the same constituents as well as it consists of similar covalent bonds. But yes, there is a difference in the arrangement of the atoms or the groups in the space. Okay, so stereoisomerism is broadly divided into geometrical isomerism and optical isomerism. Okay, so let us see about this geometrical isomerism. Okay, first here we are seeing that yes, having same molecular formula, isn't it? Molecular formula is similar over here. Okay, but here we will be seeing what there is a difference in the arrangement of the atoms around the space. How? See this chlorine, okay, and chlorine, which is attached to this doubly bonded this carbon atoms, okay, it is in the same direction. But when we see in this, it is in the opposite direction. So when it is in the same direction, it is known as cis, okay, and when it is in the opposite, it is known as trans, okay. And this gives them different properties. How it gives them different properties? See over here. Chlorine is more electronegative than carbon. So naturally you will be seeing the polarity over here, isn't it? And you can see that yes, it is more electronegative in nature. You can see that yes, the polarity is towards what? This chlorine. But when you see in this, and it is in the same direction. Okay, because both the chlorine is in the same direction. So here what happens? This becomes more electronegative, more electrons towards this upper side. But what happens in the second one? Here the chlorine is attached in the opposite direction in the trans form. As the result you will be seeing what? Whole polarity, it will be cancelled. And as the result here we will be not seeing that yes, the electrons are tended towards one side. Okay. Now coming to optical isomerism. See what happens in optical isomerism. Here we see the structure in 3 dimensions. Okay, and in this we are seeing that this carbon, okay, is having different groups. Okay, and as it is having different groups, okay, they are known as what? Chiral. Okay, and here this carbon you can see carboxylic group, alcoholic group, methyl and hydrogen. Okay, so this is optically active as it is chiral in nature, consisting of all the different 4 groups around it. Okay, so now let us understand this in a more elaborate manner. Okay, beta. So here you can see this is the structure of a carbohydrate. Here we are seeing with more explanation with the structure of protein. Okay, this is what? Aniline. Okay, now we have studied earlier that how we represent the compound on the paper. Okay, the plain linings shows that yes, it is on the plane of the paper. Okay, here we see if it is a dashed form, wedge form, it means that is away from the paper, it means on the back side. And here if it is shown by totally solid, okay, so this shows that it is towards, okay, in front. So in this way the 3-dimensional structure is represented on the paper. So here we can see that in this what happens, this optical isomerism, when we say it's of 2 types, dextro and levo. Okay, so what is this dextro and levo? In this, it rotates, when it rotates the polarized light, okay, towards the right, it is known as dextro. And when it rotates the polarized light towards the left, it is known as levo. Okay, so here you can see in this carbon, okay, this is the carboxylic group, okay, it is rotating towards the right. Okay, so it is what? Clockwise, and it is known as dextro. And when we talk about the levo, you can see that it is on the left hand side okay, the polarized light is rotated towards the left hand side, and yes, you can see that here the movement is shown in a anti-clockwise manner. Okay, so here more can be studied on this by counting the numbers, but it has to be studied in the higher classes. Okay, till class 11 you will be studying up till only here. Okay, so this is all about the isomerism. Okay beta, hope you might have understood it. Good day, take care.